everyone. My name is Vaishali Katti. I am working as an assistant professor in the Department of Computer Science and Business System. So today we are going to discuss about the Booth's algorithm. So first I will tell you what is the use of Booth's algorithm. So Booth's algorithm, it explains how we can perform the multiplication of any two-digit numbers. So before starting the algorithm, we will take one example so that you can understand how we can perform the operation, and it will be easy to draw the flowchart. Okay. So we will start. Before starting the operation, first you should know these things, that is the condition of Q0 and Q minus 1. So whenever the condition of Q0 and Q minus 1, that is 0, 0 and 1, 1, now we are going to do no operation, means only we are doing the right shift operation, and whenever the conditions are 0, 1, we are doing the add m operation, that is the contents of accumulator plus multiplier, and whenever the condition is 1, 0, we are doing the sub m operation, that is a minus m. So we will take next example. So this is the example 4 into 6. So 4 is nothing but your multiplicand and 6 is nothing but your multiplier. Okay. So first we will convert this 4 into the binary digit, binary value. So what is the binary equivalent of 4? That is 0, 1, 0, 0. And what is the binary equivalent of 6? That is 0, 1, 1, 0. Now for performing the operation, we need minus m value also. So how we will calculate the minus m value? As everyone knows, in digital we are doing the minus n operation by using 2's complement number, right? So we will take the 2's complement of plus 6. So how we will do this 2's complement of plus 6? We will start from the rightmost side. Okay. So till 1, whatever digits are there, keep as it is. Now you can see here, and the number is 0, 1, 1, 0. So rightmost digit is 0. 1 till 1, keep the digits as it is, and after this take the 1's complement of a number. So what is the 1 complement of 1? That is 0. And what is the 1's complement of 0? That is 1. So finally minus m value is 1, 0, 1, 0. Now what we will do? We'll do this operation, and what is the expected output? The expected output, it should be 24, right? So we'll do this operation. Now first see here. Now you can see here first operation. So in the operation we'll write first here initialization. Okay. Now initially we will take the contents of accumulator as a 0, 0, 0, 0. Now you say that how many times we are going to do this operation? That depends on the number of bits of your multiplicand. So how many bits are there? Total 4 bits. So we are going to perform the 4 times these operations. Okay. So what is the value of multiplicand? Here you can see 0, 1, 0, 0. Initially we will consider the value of q minus 1 as a 0. Now what is the value of multiplier? First we will take plus m value. So what is the value of plus m? That is 0, 1, 1, 0. And what is the value of minus m? That is 1, 0, 1, 0. Right? Okay. Now first what we are going to check, as we have discussed just now, we have to check the condition of q and q minus 1. So what is the condition of q and q minus 1? 0, 0. As we have discussed, 0, 0 means what we are doing? We are doing no operation, only we have to do the right shift operation, right? So here we will do first right shift operation. So for right shift, what you will do? First start from the first digit of your accumulator. This digit keep as it is. Okay. Now next, do the right shift operation. This 0 is shifted to this side, this 0 is here, this 0 here, this 0 is shifted to now multiplicand, that is 0. Next here 0, 1, 0, and this 0 is again shifted to this side. Okay. So now again what we have to do? We have to check the condition of q and q minus 1. So what is the value of q and q minus 1? That is 0, 0. Again for 0, 0, which operation we are doing? There is no operation, only we have to perform the right shift operation. Okay. So for again this 0, keep as it is, 0. Now shift this 0, 0, 0. Then this 0 is shifted to this side, this 0 here, this 0 here. Now 1 is shifted to here, and here is 0. Okay. Now Next step, what we are doing? Again, we are going to check the condition as a 1 0. So what is if 1 0 is there? Which operation we are doing? 1 0 means we have to do the sub m operation. So sub m means what? A minus m value. Now here the condition of 1 0, q and q minus n 1 0. So which operation we are doing now? Sub m. Now see here, what is the contents of accumulator here now? 0 0 0. Sub m means you have to consider the minus m value. What is the minus m value? 1 0 1 0. Now result is 0 1 0 1, right? So this is 1 0 1 0, and here your contents of multiplicants are 0 0 1 1. And now this is the 1 0 1 0 and 0 0 0 1. Now again, after sub m operation, now we are going to perform the right shift operation. Again, what we are doing? This one keep as it is. This one is shifted to this side. 0 1 0 0 0. This 0 is here, and this one is shifted to this side. Okay. Now again, how many times we are going to perform these steps? For 4 times. Now this is first step. This is your second step. This is your third step. Now last step that we are going to perform. Now here again, what we are going to do? We are going to check the condition of q and q minus 1. Now as we have performed add m operation, now after that we have to do the right shift operation, right? So for right shift, again keep this one as it is here. Add m operation. First we are doing add m operation. So for add m, what is the value of m? 0 1 1 0. Okay. So you do the addition 1 1 1 plus 1 0 1 plus 1 0, and keep the contents as 0 0 0 0. Now after addition, what we are going to do? We are going to perform the right shift operation. So for right shift, what you will do? Keep this bit as it is 0 0 1 1 0 0 0. Okay. So this is the how many steps we have performed? Total 4 steps. So this at last you got this answer as a 0 0 0 1 1 0 0 0. Now everyone knows 0 0 0 1 and 1 0 0 0. As how we are going to calculate the numbers? Start from the, this is the 1 2 4 8 16, 2 to the power of 0, 2 to the power of 1, like that we have calculate. Now whenever there is 1 1 is there, here 16 at the 16th position plus at the 8th position. So 16 plus 8 is 24, and what is expected output of 4 into 6? It should be 24. So our answer is 24. So like by using Booth's algorithm, we can perform this multiplication operation. So as now, just now whatever we are discussed, you can see here what is the value of q, q0, q minus 1, 0 0. First we are going to perform the right shift operations, and total 4 times we have performed this operation. Okay, and your final answer is 24. Now by using this strategy, we can draw flowchart very easily. So how to draw the flowchart? First, which contents that we need? First, the contents of accumulator should be 0. Then initial condition, value of q should be, q minus 1 should be 0, right? So, and we have to load the multiplicand multiplier. Okay. So how to do this one? Just check this. This is the flowchart. Now first we are going to start, that is in flowchart we are showing start and end, that is okay. Now initial condition, contents of accumulator is 0, then content of q minus 1 is 0. First load the value of multiplicand and multiplier, and one more things, how many times we are performing this operation, that also we have to mention, that is count. It is denoted with the n. So first what we are going to check? We are going to check the condition of q and q minus 1. So here you can see here condition of q and q minus 1. So first, whenever there is condition 1 1 and 0 0, we are going to perform only right shift operation, right? And when the condition is 0 1, so when condition is 0 1, we are performing addition. Accumulator content is loaded with accumulator plus your m, that is multiplicand. Okay, and here when the condition is 1 0, we are performing the sub m operation. So sub m means what? We are doing a minus m. and after that we are doing the same right shift operation, and now count is decreased with 1. So as just now we took one example, in that we have performed 4 times operation. So first we will do the fourth operation, third, then second, and then 1, like that we can do. So how many times we can going to perform? Unless and until your count is 0. Okay, so once the count is 0, do the end operation. Okay, so this is the flowchart of your Booth's algorithm. Now this is the finally, so what we have discussed in this Booth's algorithm, and this is used to perform the multiplication of any 2-digit numbers. So this is, and for the division we are performing restoring and non-restoring algorithm, that we will see in the next video. Okay, thank you.